Welcome back to another system design video. Today we are going to see a mobile system design for a real-time location sharing application. Uh, in this session we will go through the detailed system design for a mobile application that supports real-time sharing, receiving and stopping of location updates, as well as showing historical data for that particular user. I'll walk you through the HLD, LLD and all of those things using some visual diagrams throughout this video. So without wasting any more time, let's get started. So you must have seen this kind of UI in WhatsApp. Whenever we share our location using WhatsApp, we can see similar kind of UI there. If my friend is sharing his location, I can see his location updates in real time. And if I also share him my location, I can also see myself on the same map. So you can use real-time location updates to define these paths. It purely depends on your use case. So this is the overview of the application that we are going to design in today's application, and we are going to see how we can create this kind of feature in our application from a mobile perspective. Let's first define our requirements. So as a user, I should be able to share, receive or stop my live location updates. I should also be able to see my history of location updates. So I can use this to show what path a user has chosen to reach from point A to point B. And even if my application goes into the background, I should still be able to share my location, and also the location should be shared even if the app is minimized. So these things can be combined, these 2 points. So let's now define some assumptions as well. Since we are going to share a user's location in real time, it is recommended to notify user that his location is being shared to honor their privacy, because we don't want to get access of users location without letting them know. And also Google restricts such kind of features where location sharing is happening without user consent or without letting them know. So this is, we are going to assume that we will be sharing like a notification kind of thing to the user while we are sharing their location. So if we talk about our HLD, so there will be mainly 3 events that we are going to discuss. One will how a user can share their location, how they can stop sharing their location, and on how a user can receive real-time location on their device. So these are the main events that we need to consider for today's HLD. So let's see how location sharing will work first. First of all, we will check for the location permission, and if we don't have, we will ask for it. If the user declines it, we will handle the rejection by showing some kind of UI to them that they have to accept from settings to access this particular feature. And if they choose to accept this permission, in that case we should start listening for location changes using some location service like GPS, or we can also use internet to get location updates, but ideally we should use GPS to receive location updates for these kind of scenarios. In this point, we have registered some kind of location service or location provider which listens to changes in location through GPS. And if any location change detected, so there can be 2 possible cases. If no location change is detected, in that case do nothing, like the user is in the same location. And if location change is detected, so in that case we will trigger an API request with the recent location and we will give it to our backend. Now how the backend will work, so this is an overview of the backend, so I'm not sure if this is accurate or not. So most probably in this kind of application, when we trigger the API request with our location, it goes to a message queue like Kafka and all, and that message queue is responsible to deliver that location to multiple services like SSE service. SSE is basically server sent events. We'll see later on how we are going server sent events for real-time updates. We can also use WebSockets here or long polling, but I think we should use server sent events, because server would be sending events to the receiving client. So we'll see how this works in some time. And another thing, the message queue should update analytics service, or for historical data we can have a location DB kind of thing, in which we are storing these locations into a particular DB for that particular user. So we are not going in deep how the backend works, but we are mainly interested in this SSA service and this location DB thing, and we'll see how we are going to use them later on for our use cases. So let me just go through it again. So I'll just select this and drag this up. Okay, so let me just go through it again. So whenever user start sharing their location, we will check for the permission. If the user declines it, we will handle the rejection. Otherwise, if the user chose to accept, we'll start listening for location changes using some location service or location provider. And if any location change is detected, we'll simply trigger an API request, which will then send that particular location to a message queue. Then this message queue will be responsible to deliver that location to multiple services, where we mainly concerned about server sent events and location DB. So this is the overall flow diagram for sharing location. And since we have started sharing our location, we should discuss how we can stop sharing our location. So this will be whenever we want to stop sharing our location, we can trigger a same API request with the status, let's say stop, and we can also send the recent location along with the status stop. And now this will again go to the message queue. It will update the location DB with the recent location. Because we are also sending that. And now when this SSE service will receive this status stop, it will simply close the connection with the client. So this is very straightforward. So for stopping our location sharing. Now let's see how the user will be able to receive location on their devices. That is more crucial over here. So now let's discuss how the data flow for receiving location on a client looks like. So in this case, we are going to use a local DB to store our received location, and then we will drive our UI from our local DB. Now why we are doing this? So let's say for some time we don't have internet, we are in a place where we don't have that much of internet, and our SSE connection gets broken for some time. So in that particular time frame, we won't be able to show the last updated location for that particular user. But if we derive our UI from our local DB, so in that particular case also we can still show our user their last updated location. So one question may arise, like we are using local DB over here, but we are not using local DB while sharing our location. So if we see over here, in this case, using local DB will be an overhead. Technically, we can use local DB when this API request gets failed. We can store the failed sent location in a local DB, then we can resync it, but that will be an overhead, because so even if we resync it in a later point of time, it will be an outdated location. It won't be of any use for us. So that's why we don't need to use local DB over here. And but to power our UI, to display it on the UI while receiving location, we can use local DB to power our UI. So when we start receiving location, first of all we will clear our local database. So it's also based on your use case. If you want to persist your previous location histories, then you can also do that. You don't need to clear your DB. You can simply add more rows to it, and based on session IDs you can filter them out. To keep it simple, for now I am treating every session as a fresh one. So I'll just clear my local database, so I don't have my previous location histories in my local DB. And then I'll do two things. First, I'll start observing my location updates from my local DB, and from that I'll power my UI. So as soon as some data gets inserted in my local DB, I'll just use them and display it on my UI, whether just showing lat long, or I can just use Google Maps or any kind of maps and display it over there. after doing this, the second thing I want to do, I want to connect to the, so remember I have a SSE service over here. So when we were sending location updates to the message queue, it is updating one SSE service. This SSE service is server sent events service. So servers and events are mainly responsible for sending a stream of data from server to the client. So for real-time updates, there can be multiple options. So first one is polling, in which we make API calls after every second or after every 2 seconds. And another one is WebSockets, in which it creates a bidirectional channel where client and server both can send and receive data in the form of streams at the same time. And the third one is server sent events, that is SSE, which you are going to use in this case. It is similar to WebSockets, but it can only send data from server end as a stream of data. So client won't be able to send any kind of data to a server, and that's what we want over here. While receiving any kind of location, we are dependent on our server. Like whatever my server will tell me, I'll just accept it as truth and display it over my UI. Now this SSE service, what this will do, so this now here if we see, we'll first try to connect to this service via some URL and start listening for incoming events. And if the connection is closed, so when we have seen over here that when we stop sharing our location, we are simply telling our service to close the connection. So when this connection will be closed, it means the location sharing has stopped, and in my particular case I will clear my local DB, but it purely depends on your use case. How do you want to preserve your data? Now when we start listening for events, so let's say an event received. If nothing received, then do nothing. And if some event is received, we will simply update our local database. And as soon as we update our local database, here we are observing on our database, it will simply display it on our UI. So if we are showing it over a map, we will simply update the marker to a new lat long. So this is the overall flow diagram for receiving location from the service. And also if you see over here, when we are listening from this service, it is getting the events from message queue. So message queue is something that works on a subscriber and publisher kind of thing, and the backend folks can explain more about this, like how this works. But all I know is this is some kind of queue in which works as a subscriber and a producer kind of thing. These services will be subscribed to it, and this will act as a producer, and as soon as we trigger some request, these subscribers will get updated. So this is the overall HLD for our sharing, stopping or receiving location. So now let's see how the LLD will look like. So let's first define our endpoints, like what kind of endpoints do we need. So if we talk about this, here we are triggering an API request to send our location to the message queue, and here also we are like triggering an API request to send the location with the status stop to the same message queue. So this can be combined in a single API request, and this can be a post request because we are updating the location, and this will be the endpoint /API/location. The request body will look like this. We will pass latitude, longitude, the user ID, timestamp, and one status. So status can be either track or stop. So if we want to continue sharing our location or start sharing our location, we can say status as track. And if we send status as stop, it will simply ask the SSE to close the connection and stop location updates. And in the response, we can simply return either the request was successful or not. Okay, the second one is SSE URL. This is the URL which we will use to make our connection for receiving updates. So in this thing, when we try to make a connection to our SSE service, in that case, we can use this URL to make the connection, and in the header we need to add this content type that is text/event stream. And the event data can look like this, where there will be a session ID. So let's say I have shared my location with person A in the morning, and in the evening also I'm sharing my location with the same person. In that case, there will be two sessions. These two sessions will have their separate IDs. So in the response, we can get a session ID, latitude, longitude, timestamp, user ID, and also user image if we want to display it on our UI. Okay, I don't think this should be a list. This can be a single object, because the list is unnecessary over here. We just need the latest location update, and we are already storing in location in our local DB, so we can get the previous location updates from our local DB only. From this HLD, I guess these are the two URLs that we need, but in the requirements we also need to show the location history of a particular user. So ideally we can have it from our local DB, but if somehow we want to get the fresh data from the server, we need to have an get API for location history, in which we can pass session ID, like for which session we want to request location history for, and we will pass it in header for security concerns. We can't pass it in query params over here. And this session ID, there will be another API of sessions, in which we can use how much sessions are there for that particular user ID, and we can get a list of session IDs, and for a particular session ID we can then make an API call for location history, in which now I can get list of locations in the same format like this session ID, which will have a session ID, lat long, timestamp, user ID, and user image. So these are the required endpoints, I guess. Now let's define our entity, or let's say model. So in this case, we will have a common model or entity. For our current use case, we don't need any DTOs over here or any mappers. We can simply use a common model for our local DB and to display it on the UI. So this location model will have a session ID, which will be a string, then a lat long, which can be a pair, or for now I have taken it as a string only, a timestamp, user ID, and user image. User image, again, it will be an URL, so it's a string. So this will be our model. Then some kind of permissions, for specifically for Android, we need some kind of permissions. So let's say internet, obviously we need to make API calls. Then this two location permissions. So this course location gives us approximate location. It is not that accurate, but this find location gives us the accurate location from GPS. And also we need to use one foreground service. So in the requirements, we have seen that we want to share our location even if the app is in background or is in minimized state. So we can use a service for that, but specifically we are using foreground service. This foreground service helps us perform tasks asynchronously while notifying the user that a service is going on for this particular application, and you can track it over here. So this foreground service is recommended by Google for these kind of use cases only. So now this, as mentioned, we will use a foreground service which will act as a service in Android. To perform this location updates in the background, we can launch a Cortin scope which can run on IO dispatcher, and in that particular thing we can use this particular location provider to get us the accurate and precise location of that particular user. So these things are available very easily on internet. There are lots of samples provided by Google, so that how we can implement this kind of service in our application. And so this is the main thing that we are going to follow. Other than that, obviously we need to register this service in our manifest and all. That's a pure Android kind of thing, so I'm not going to go into that. From overall mobiles perspective, I guess this is enough to build real-time location sharing feature in our application. So I guess this is it for this video, and today we have designed this particular feature for a very straightforward and simple use case, but it can get more tricky as we introduce more and more complexities to it. If you have any questions or any concerns, please drop them in comments or DM me on LinkedIn. I will be happy to respond there. So yeah, I guess we are done, and see you in the next one. Thank you.